Tēnā koutou. Welcome to Science with Folly. Today, we are looking at balancing chemical equations. And we're really only going to be looking at simple chemical equations, just to get you started. Now remember, in a chemical reaction, we write a chemical equation with the reactants on one side and an arrow showing the reaction and the products on the other side. Now, chemical reactions and chemical equations are based on the law of the conservation of mass. And that states that the reactants have to equal the products. Pretty simple. The same amount of stuff on this side has to be on this side too. Of course, it is reacted and changed into different things, but we still have the same amount of mass on each side. So let's start with a really simple chemical reaction. If we have sodium metal, Na, and we react it with chlorine gas, Cl2, our product is NaCl. Pretty easy. Sodium, as you know, it's a highly explosive metal. I find it quite amazing. If I ate some sodium metal,
3,500-pound container of sodium hurtles into the lake and crashes through a foot of ice. As the water seeps in, smoke rises through a series of muffled explosions.
wouldn't be very good. Or chlorine gas, really poisonous gas. If I took a big lungful of that.
This is the latest weapon in the arsenal of the self-proclaimed Islamic State. Oxygen. The cloud of orange is chlorine gas.
Ooh. But react it together, and what do you get? Salt. Salty. Where's the fish and chips? Now, when we look at this chemical equation, you can see we've got one sodium atom on this side, and we've got two chlorine atoms on this side of the equation. But over here, we have one sodium atom, and we have one chlorine atom. So it's not balanced. Remember, the law of conservation of mass says we have to have the same amount of mass, or the same amount of atoms on each side. So what do? Well, I double this compound here, and now I have two sodiums and two chlorines. Over here, I put a 2 in front of this, and now I have two sodiums, I've still got two chlorines, and the whole chemical equation is balanced. Here's another one to look at. We've got calcium plus hydrochloric acid, and it gives us calcium chloride and hydrogen gas. On this side, we have one calcium, we've got one hydrogen, and we've got one chlorine. Over here, one calcium, two chlorines, and two hydrogens. So it's not balanced. What am I going to do? Pretty simple. Double this hydrochloric acid compound, and now we've got two hydrogens, two chlorines, and it's all balanced. And here's one more to try out before we finish. It looks a bit tricky, but it's not as hard as you think. We've got one lead, one hydrogen, and let's keep this ion together, this nitrate ion, NO3. We've got one of those. Over here, one of these, two NO3s, and two H's. What are we going to do? I think you've got it. Two in front of the HNO3, which is nitric acid, and now two of those, and it's all balanced. It's a piece of cake. Thanks for watching. Hope you've learned something. Now, obviously, balancing chemical equations gets a little bit more difficult with more complex equations, but I just wanted to start you with the easy ones. And if you follow those rules that I was showing you, it's not too hard. That's all for now. Ka kite anō.